This should be a pretty short video, so I'm not expecting you guys to have a ton of difficulty with it. That being said, if you do, make sure you let me know as soon as possible. So we're going to be dealing with ratios, which is a fancy term for fractions or a comparison of two things. Ratios can look like any of these three things. It can be 4 divided by 6 as a fraction. It could be 4 colon 6 or 4 to 6. They all mean the same thing. It's comparing one thing to the other. Apples to oranges, bananas to tomatoes, whatever. Okay? And so any of those three forms is okay. I prefer fractions, and I think you will too, because it's just what we've always been doing. So if we have these three things here, apples, bananas, and oranges, and we want to make a ratio of apples to bananas, well, that would be 6/4 apples to bananas. But if we made that proportion, or not proportion, ratio, we would want to simplify it down. Well, we'd divide the top and the bottom by 2 and get 3/2, like that. Okay? If we wanted to do oranges to bananas, that would be 3/4 oranges to bananas. Well, that one can't be simplified, so we're done. And bananas to, I don't know. Let's do oranges to apples. We haven't done that yet. Oranges to apples. Well, that would be simplified down into 1/2. Another thing about ratios, you want to leave it like this, because if you do 1 and 1/2 apples to bananas, it's still possible, but it's really confusing to look at it that way. So improper fractions are better than mixed numbers here. Okay? Here we have the MCM Middle School. I think this is actually a couple years ago, where we had 29 8th graders, 29 7th graders, 28 8th graders, and then 11 7th and 8th grade teachers combined. I think that's changed a little bit. But for the sake of argument, if we wanted to do teachers to 8th graders, that would be 11/28. Teachers to 8th graders. If we wanted to do 7th graders to teachers, that would be 29/11. And you're noticing here the order matters. Like what I just labeled incorrectly there. The order matters on these types of problems. Because if you're saying teachers to 7th graders, that would be backwards. This is 7th graders to teachers. And then if we wanted to do 8th graders to 7th graders, 28/29, 8th graders to 7th graders. And it's always important to label these ratios if you can, because if you don't label them, it's very hard to tell which is which. Okay? Now, I have found a bunch of rectangular things in my classroom. I have my wallet that's 7 inches wide and 5 inches long. My smartboard is 5 feet wide, 4 feet long. My iPad's 1 foot long, 8 inches, and the whiteboard is 9 feet and 48 inches. And I want to know if all of these ratios match up width to length. Now, I'm hoping you see that there's a problem with a lot of these. This inches to inches is fine. That becomes 7/5. Nothing wrong with that. But if we look at the smartboard's 5/4, but it's not inches. Well, if it's feet to feet, then it's fine. We can do 5/4. Nothing wrong with that. But the iPad does not match up. That ends up being 1 foot equals 8 inches. Well, if I turn this into 12 inches, now they do match up, and it becomes 12/8. But that can be simplified into 6/4, and can be simplified again into 3/2. So far none of them match up. And the last one we have, whiteboard, is 9 feet and 48 inches. Well, you could turn 9 feet into inches, or you could turn this into 4 feet, because now we have feet and feet, and this becomes 9/4, which cannot be simplified. So actually, all of my rectangular things in my classroom have different ratios, even though they look similar, which is kind of interesting. Okay, and for a quick review to see if we understand the concept of ratios, I would like you to do these three and simplify them and see what you get. Stars is 6, and there are 5 circles, so 6 to 5. There are 5 circles and 3 squares, so that's 5 to 3. And square to star, that's 3 over 6, which simplifies to 1 over 2. Alrighty, and that's it. That's everything. I think there's one section, maybe 2 online, but either way, it's not terribly difficult.